Alright, welcome back. For this video tutorial, we're going to look at thermal equilibrium. For this problem, we have a beaker with water in it, and there's 100 grams of water at 80 degrees Celsius. And then inside the water, we have a piece of glass, and the glass is 20 grams worth of glass, and it is 20 degrees Celsius. And we want to find out what is the temperature where it's going to be equilibrium, which is also the final temperature. Okay, so we have an equation, and our equation is the heat lost by the water equals the heat gained by the glass. This is because energy is always conserved, not created, not destroyed, but equal. So whatever the water loses, that's the negative, has to equal with the heat that the glass gains. And we know that Q equals mc delta T. So I can rewrite this as this. Okay, and this is the equation I'm going to use. I'm going to keep the left side as my water. And it's my water because it's the one that's losing the heat. It's the hotter one. That's why it has that negative out front. And the cold one is the glass. So this is my glass side. Okay, so I'm going to start plugging in numbers. So for my water side, the mass of the water, the C of the water is going to be always given to you in a chart. I gave it to you at the top there. It is 418. The final temperature, we don't know, but we know the water starts off at 80 degrees. The glass side, the glass has a mass of 20. The specific heat, C, is always going to be given to you in a chart. It is 0.84 for this one. And then we don't know the final temperature, but we know it starts at 20 degrees. So we're going to solve for TF here. And we're able to do that. So we get negative 418 times TF minus 80 equals 16.8 TF minus 20. So from here, I could distribute. I can distribute let's see, I could distribute the 418 into both, and I could distribute the 16.8 into both. However, that is going to give me very large numbers, and it's going to make things a little harder than I need to make it. So that way does work, but I'm going to do something different. I'm going to divide both sides to make my numbers smaller. So I'm going to divide both sides by 16.8, and then what's going to happen is when I have 418 divided by 16.8, I get 24.88. And on this side, I just get TF minus 20. So you can see by not distributing right away, I'm making my numbers smaller, makes them just easier to work with. And now I'm going to distribute. So now I'm going to distribute this 24.88 TF. I have a negative over here and a negative here, so that's going to make a positive. And it's going to be positive 1990.48 equals TF minus 20. Okay, I'm going to get like terms together. So I'm going to add 2488 to both sides. And I'm going to subtract 20 to both sides. Sorry, add 20 to both sides. So this is going to cancel. This is going to cancel. And what I'm left with is 1990 plus 20, which would be, let me switch colors, which would be 2010.48. And on this side, I have 1 TF plus 24.8 TF. And I get 25.88 because it's 1 plus 24.88. And then the final step, I can divide. So all of these problems will be done the exact same way. And like I said, you don't have to do it the way I do it. You can distribute right away. But I think this way does make it a little bit easier. And we get a value of 77.68 degrees Celsius. And that is my answer. All right. Thank you for watching. I hope you understand it. If you don't, please come by and see me or shoot me an email and I'll be happy to answer it. And I'll see you guys next time.